All right, good afternoon. Happy Thursday. Okay, so last time we talked about exponential decay, which is real similar to exponential growth. Instead of rising exponentially, it's falling. It's exponentially falling. So I'm not sure if I did, in the practice. Well, first of all, yesterday or Wednesday, I wanted you guys to do a practice sheet. You guys were all doing the wrong sheet. So in the practice, it's under practice. There was exponential growth and decay and writing equations. So I don't know if you were doing the right sheet or not, but I did not want you on when you weren't supposed to be working on practice AB. You were working on a practice that I set up for just Wednesday. So now I'm talking about practice AB. So on practice AB for 13.2, did I do problem number 1 with you? And do you know how to do problem number 1?
No.
Okay, let's do that first. This is the exponential decay 13.2. This is problem number 1 on practice AB. So you have a table. And you start at 0. And then the numbers are 36, 27, 20.25. And the last number is 15.1875. And if you look at this, it is falling. It looks like, it doesn't look like a line. If you graph these points, it does look like exponential decay. So we don't know anything, but it does look like exponential decay. And then the next thing I would look at is there a common difference or a common ratio? Because if there is, we know that the geometric sequence is an exponential function. So go ahead and do this right now. See if there's a common difference, and then see if there's a common ratio, because that will help us out with the equation. And let me know. Also, let me just announce something real quick. You probably already realized by now, I disabled the chat. And it's not because I don't like the chat. I do like the chat. The problem is for when I'm teaching, it's almost like I need a secretary or I need someone to look at the chat. I can't do both. So I do like the chat feature, and I'm going to turn it on right now because I want to know if you're present or not. So if you're present, put a P in the chat. Okay. Let me turn it on first. All right, so if you're present right now in the class meeting, just put a P in the chat. All right, did anybody find out anything here?
I got 3/4.
Oh, so that there is an exponential, so that there is a common ratio?
Yeah, I think it was 3/4.
Okay, now we are working with decimals, so you do want to give me a decimal. So you took 27 divided by 36 and 20.25 divided by 27. And what'd you get on the calculator?
3/4.
Working in decimals? 0.75. So this is a geometric sequence. Well, if this is a geometric sequence, can't you use A times R to the N or whatever it was? I can write any letter I want. Isn't this what it is? So if we know the common ratio is 0.75, don't we know the first term? So let's take a look at this. Let's test it out. If you put a 0 in for x, you're going to get 36 times 1, which is 36. So that worked. But that doesn't mean all of them work. So now when you put a 1 in there, on your calculator, what's 0.75 times 36?
27.
So that one worked. Let's do one more. If you put a 2 in there, what's 0.75 squared? Hit enter and multiply by 36.
20.25.
So you see what I'm thinking, right? That, yeah, that's probably the function we're looking for. All right, now I don't care if you did this or not. I want you to do it again. So grab some scratch paper and you're going to do number 2 on practice AB. So right now in class, you're going to do problem number 2 on practice AB. And then we're going to check our answers. All right. When you finish this, can you put an F in the chat if you finish this? Or I should say when you finish it. We have 2 people finish with it. Put an F in the chat when you finish it. All right. All right. Got a whole bunch of people. All right. So what did you get for the answer?
I got f of x equals 21 parentheses 0.25 to the power of x.
That's correct. And if you check it, it will match the table. So that's the whole thing, is you have to figure out, is it linear? Is it a quadratic? Is it cubic? What is it? And if it looks exponential, try a geometric sequence function, because a geometric sequence function is exponential. All right. I am actually going to teach a new lesson today because the E number is just exponential growth. So there's nothing really new to teach. Do you guys want to ask me anything though about decay?
I know last lesson you real quick gave us the decay function, but I didn't get to write that down. Could you write that down again?
It's it's the same. It's the
Just subtracting now?
Yeah. It's
Okay.
Are you talking about the exponential decay function? I was going to teach that, right? Because I didn't Okay, so let me finish that. I'll do that.
Okay.
So in lesson 13.2, I was going to show you a modeling problem, at least one. So we wrote an equation, but let's do a modeling problem, okay? Or one or two. All right, so we're back in lesson 13.2. We did the transformations, we wrote equations, and now objective 3 was the modeling. And now we have the exponential decay function. And it looks like the exponential growth, f of t time, is a times 1 minus r. So now this is the decay factor, that whole thing. R is the decay rate. 1 minus r is the decay factor to the t power. And I'll just write this over here. This is where a is greater than 0 and r is a constant percent decrease. It's a constant percent decrease for each unit of increase in time. Let me check something really quick. Bear with me just a moment. Okay. So given that, let's look at page 658. Let's look at a problem on page 658. You're going to need your calculator. So on page 658, this is A. Let's read the problem. Well, actually, the directions say, give the description of the decay terms, write the exponential decay function, and then graph. So they do want the exponential decay function, and here's the problem. The value of a truck purchased new for 28 grand decreases, and that tells you whether it's exponential growth or decay. So it decreases by 9.5% each year. Write an exponential function for the situation and graph it using a calculator, and then use the graph to predict how many years the value of the truck will be 5,000. All right, so first of all, we want to figure out what these are. So A is going to be the 28,000. R is the percent, and R is always the percent. It's 9.5%. And remember, percent means per 100. So you have to move the decimal 2 places, 0.095. Sometimes people put 0.95. That's wrong. It's 0.095. So let's put it in here. So F of T is equal to 28 grand times 1 minus 0.095 to the T. Now, I don't care if you do that by hand or on a calculator, but you have to line up the decimals. So what's 1.0 minus 0.095?
.905.
0.9, thank you. Right, so let's look at the problem again. It says use the graph to predict after how many years the, okay, so first of all, this they want. So this is the function. And they want to know how many years after the value of the truck will it be 5,000. So what we have here is 5,000 isn't time. 5,000 is going to go in here like this for our equation to put in the calculator. And so your y sub 1 is going to be this. And hey, you know what? Check this out. We can simplify that first if you want. I'm going to divide by 1,000. And if I divide by 1,000, so that's nicer. It's probably not a good idea though. If we get by hand, go for it. Since we're using a calculator, we'll do the actual graph. So you realize if I divide by 1,000, our answer is going to be correct, but our graph is going to be deceiving. So let's just leave it like this. So we'll wait, y sub 1 is equal to 28,000 times 0.905 to the T. And our y sub 2 is going to be 5,000. So that means that you're going to want to make your y go from like 0 to 10,000, counting by 1,000 on your y. So you have to go to the window, put these in the equation editor, go in the window, and under y min, put 0, y max, put 10,000, and under y scale, count by 1,000. And remember what you're trying to do. You're trying to find the point of intersection, and you're going to get some x, and your is going to be 5,000 because we already know that it's the y value is going to be 5,000, right? And our answer is going to be the time, which is going to be x, which is going to be that value right there. Go ahead and see if you can graphing and everything else. Did you get it figured out?
I got 17.
17.26. So depending on how they want you to round, you would say the value will be 5 grand. So that's your X and Y, that's your time, and your 5,000. Who answered that? Was that Abraham or Pedro?
That was me.
Pedro, can you share your window setting, please?
Sure, but mine barely fit in there. The X was 0, the min. The X max was 1,000. The X scale was 10. The Y min was 0. The Y max was 10,000, and the Y scale was 1,000.
Okay. So in the chat, if you understand what's going on and you were able to do it, can you put a T that you found in the time? Can you put a T in there, please, so I can see how many people get this? If you understand this and you were able to do it on the calculator, can you put a T in the chat? All right. Let's try one more. Okay, this time you have to turn to page 659. Read with me, please. The value of a sports car purchased for $45,000 decreases by 15%. So that would be point, because percent means per 100, so divide by 100. Each year. Write an exponential for the depreciation. So depreciation means decrease of the sports car, and plot along with the previous after how many two vehicles have the same value if they're purchased at the same time. So we need to keep this going. And now we have f of t is equal to 45,000 times 1 minus 0.15 to the t. So let's simplify this. It's going to be f of t is equal to 45,000. What's 1 minus 0.5? One minus 0.15.
0.85.
Now, somebody tell me, how do we solve this problem? They're saying, after how many years will the two vehicles have the same, that means equal, same value if they are purchased at
With
the same time. Good.
We'd put the value from the first one. If we're going by the 5,000, we'd put it equal to the formula we just got now.
So are you saying put that equal to that?
Yeah, I think.
Okay. So
Yeah, actually.
28,000 times 0.905 equals 45,000 times 0.85 to the t. And can't you put this in the calculator? Find out where they cross?
Yeah,
So go ahead and do that. And this time you're going to read the whole ordered paragraph. So Phil, when you're done, tell me the point of intersection, please. Tell me the whole thing. So you had the window for this one. Now you got to fit this guy in.
I got it. I got 7.56, and does it want the other value too?
Yes.
I
So
got
this is
13,155.
hold on. This is 7.
Oh, sorry.
This is 7.57.
Yes.
Oh no, but
And then
it
the
might
Y
say
would be,
hold on a minute. They might say round to 3 decimal places. I don't know. So put 5, 6, 7. And then what was the Y value?
the Y value was 13,155. And
You cut out. What'd you say?
it was point 4046.
0.4.
0.446.
Okay, I'm kind of rounding. So depending on how they ask you to round. But basically, here's what we found out here. We found out that this is 7.5 years about. So it took 7.567 years that the values of both are going to be $13,155, or we should say about. So we actually used the whole intersection to answer this problem. The first number, remember, is t, time. And that number right there is telling you, since we equated them, when both cars will be the same value, and that's $13,155. All right, so this was part 2 of lesson 13.2. And now I want to talk about 13.3. I don't have a whole lot to say. Do you guys have any questions? Okay, in the chat, if you guys understand, can you just put a C for car in the chat if you get this? A C for car? Yeah. So now we're starting to see the value, the true value of the calculator, when the numbers are really big and we don't, but notice that if we did not know how to do this, we couldn't use the calculator. The calculator is only as useful as the use of it. So if you don't know how to do the problem, what good is the calculator? You wouldn't use the calculator. So it's always important to conceptually understand the math, and the calculator is going to be a great to help us out. All right, this lesson is called base E. And you know pi is 3.14. We the other day, 311. I mean 314, sorry, 314. And this E number, it's used in science. It's a number. And the number, we don't even care about the, I always have to look up the value. The number is about 2.7. So all you need to know is its growth. So whatever you do with the exponential growth is what you're going to do with the E number. So this is California Common Core Standard. Same thing, BF 0.3. And I have in my notes to do the Explorer. And I'd like to show you the parent. So the parent is the graph f of x equals e to the x. So it's growth. So if you were going to graph this, we're going to do the same thing we did with the exponential growth. We're going to get 2 points, a horizontal asymptote at y equals 0. Pick a 0. What's e to the 0? 1. Pick another number 1. What's e to the 1? E, which is about 2.7. So go and graph this thing. Also, we know there's a horizontal asymptote at y equals 0 because it is an exponential growth function. So 0 up 1, right 1 up 2 out of 7. So this 2.7 is 2 and 7/10. So that's 2 and 7 out of 10 parts. So 2 and 7 out of 10 parts. That's it. So this number is about 2.7. So exponential growth function. So that's really it. Just need to remember that E is about 2.7. And since E is a decimal, feel free to use the calculator. So transformation. So for example, let's say they want us to graph g of x is equal to 3 times the parent E to the x plus 1 plus 4. Well, this is the parent. So we already have the points. 0 up 1, right 1 up E. And we have a horizontal asymptote at y. State the transformation.
It would be left 1, vertical stretch of 3, and up 4.
Yeah. Good. All right. So there's no reflection. So this guy is just going to look like regular exponential growth. So left 1 would be -1, left 1 would be 0, and the y stays the same. Vertical stretch by 3 means the y value. So now you use your calculator. You have an E number on your calculator. What's E times 3? What's E times?
$8.2.
So 8 point, and that should be a 3. And finally, up 4 means up 4 would be 7. Whoops. That's 4.2. You guys okay?
Yeah, it makes sense so
I
far.
think this Are you sure this was 8.2? Because in my notes I have 8.1.
It was 8.15 and I rounded it up to 8.2.
Okay, that's fine. Okay, so we go to graph this. Well, not so fast. Who's going to move a horizontal asymptote?
Yeah, you have to
Okay.
move the asymptote up because of the +4.
Good. So there's a horizontal asymptote at equals 4. And we're going to graph left one. I didn't leave enough room. Left one up 7. Let me erase this thing over here. Hate when that. Most of the time when I'm doing a problem, I'm paying attention to how I'm graphing because I kind of see it in my head. This time I didn't, obviously. Messed it up. Let's try it again. Okay, so we have an asymptote at y equals 4. We're graphing left one up 7. And we're graphing 0 up 12, about 12.2, 12 and 2/10. So 7, 8, 9, 10, 11, 12, 2/10. And this is exponential growth. What's your domain?
Would it be all real numbers?
Negative, I'll run.
What's your range?
4 to infinity?
4 and over, yeah.
Yeah,
4
don't
and
touch 4. Open on 4 up forever. So if they ask for the domain and range, there it is. And don't forget to move the asymptote up. So that's really about it, guys. I mean, I really have nothing more to say. You want to treat it just like the lesson for exponential growth. The only difference is with E, you're going to use 2.7 and a calculator. I do want to do a problem though. Are you guys okay with writing the an equation?
Yeah, I think we're good.
All right, let's look at a modeling problem then. Can you up your books to page 672? I got to say something first though. All right, you can have g of x equals e to the cx. Oh, look at that. They threw in a horizontal stretch of compression. Horizontal stretch of compression, calling it c. Or this could be written as g equal to e to the c times to the x power. So either way, it's the same thing. So it could be this or that. And I'm giving you that for a reason. So let's look at the page I told you, 672A. Read with me, please. This is a stock market problem. and they're asking you to solve the problem using a graphing calculator. Then determine the growth rate or the decay rate. So now we have to determine the growth rate or the decay rate. We already know what that is. It's the R in the other formulas, right? All right. So it says the Dow Jones Index is a stock market index for the New York Stock Exchange. The Dow Jones Index for the period 1980 to 2000 can be modeled by that equation. So I'm going to write that down. So it says V sub DJ for Dow Jones of T is equal to 878 e to the 0.121t. Interesting. Where t is the number of years after 1980, determine how many years after 1980 the Dow Jones Index reached 3,000. So don't forget what the variable is. They want to know what t is. All right, so watch how I'm going to do this. Okay, they asked us to find the growth rate, so let's find that, okay? So they asked us to find the growth rate. And this is how we're going to do it. We're going to take the growth factor, which is 1 plus, and we're going to e to the c. So that's why you saw me write it like this. So remember that this 1 plus r is the growth factor. And what we're going to do is we're going to actually solve for r. So check this out. So we have 1 plus r is equal to e. And in this problem, see how this problem looks exactly like that? So we know that c is 0.121. So we're going to put this 0.121 power, and now we can solve for r. Well, how do we solve for r? You get the variable. So this is going to be e to the 0.121 power minus 1. And that's going to give us a decimal. And then we change the decimal to a percent. All right, so here we go. On your calculator, what's e caret 0.121? Hit enter and subtract 1.
I got 0.13, but there's a bunch of decimals, and I just rounded it.
I don't care. That's good. So the growth rate is about 13%. And we do not need the R. They just wanted to know what the growth rate was. We don't need the R to solve this. So to solve this, we're going to do the same thing we've always done. We're going to take the 3,000, right? And set it equal to 878 e to the 0.121t and use the calculator's intersect feature. So y sub 1 is going to be 878 e to the 0.121t, and your y sub 2 is going to be 3,000. And now your y, you want to put it from like 1 to 5,000, counting by 1,000. And you're going to tell me that the point of intersection, we want t, right? And is it tx? This is going to be 3,000. All right. What you get? Tell me what the time is when you get it.
I got for the X, I got 10.154, and I'm not sure how
It's
you want to round that.
10.2. It's 10.2, yeah.
Okay, and then for the Y, 3,000.
Right. So the Dow Jones Index reached 3,000. Okay, that's right. After about 10.2 years. Or if you want to figure it out, or after 19. Now, what I'll tell you about C up here, C can be positive or negative. C can be positive or when you're ready, we're going to do one more problem. This was the growth. Were you guys able to get 10.2?
Yeah.
Can you guys put a Y in the chat? You were able to get 10.2?
Could you guys tell me what you guys used for the window?
Yeah, who had a good graph? Can you share the window, please?
I used my X min was 0, my X max was 100, my X scale was 1, my Y min was 0, my Y max was 4,000, my Y scale was 10, and then the X rest is 1.
All right, thank you.
Let's try one more problem. This is on page 673D.
Miss Birch, when I try to graph my my problem, it says errors and then it says quit.
You have a syntax error. That means you didn't input it right. So you
Okay.
probably, you might have used a negative instead of a minus or a minus instead of a negative, but if there's an error like that, it means you didn't put it in right.
Okay. I'll check it right now. Thank you.
All right. So we're looking at B here. Let's see this problem. Oh, the Nikkei index, 225 index, and that's another stock market thing, is a stock market index for the Tokyo Stock Exchange. The Nikkei 225 index for the period 1990 to 2010 can be modeled by this. And they give what? 23,000. Three, 8, 1. That's crazy. T is the number of years after 1990. Determine how many years after 1990 the Nikkei 225 index reached 15 grand. Okay, so first of all, remember our directions. They want us to find the R. So this time we want to find R. If it's negative, we want to use 1 minus R equals e to the. And remember 1 minus R, that's your decay factor. And here we go. So we have 1 minus r equals e to the, this is in that form, negative 0.0381 without the t. So to solve for r, we subtract 1. So we got a lot of negatives here. Subtract 1. So we're not solving for negative r, we're solving for r. So multiply by a negative, multiply by a negative, multiply by a negative. It does not affect the power, by the way. So did you hear what I said? Multiplying both sides by a negative doesn't affect the power. So go ahead, put that on the calculator. What's 1 minus e caret that thing? Now
It's
make
negative 0.039.
Oh, hold on just a second. Make sure you use a minus here and a negative there. Karina, are you listening to me? Use a minus there and a negative there.
Okay.
And what'd you get, Pedro?
It was 0.039.
Oh, yeah, 0.037. That's 9.
Yeah, I got negative 0.0388, so I just rounded it up to 9.
It shouldn't be a negative.
I got 0.0373 and so on.
Say
I
it
did
again.
too.
Same.
What'd you
I
get?
got 0.0373.
That's what I got. So now listen to this. You have a decimal, don't you have to change it to a percent? So don't we have to multiply by 100? So that'd be 7%. So that's your decay rate. It's 3.7%. Okay, let's come back over here and do the problem. So the Nikkei 225, they gave us 15,000 is what we're going to put in here. And we are going to use the calculator. And once again, you guys understand why I'm not simple. Usually you always see me simplify. But the reason why I'm not simplifying, because you know the graph will be messed up. So see, we can solve and get the right answer, but when we're graphing, if you mess with this, you're going to get the wrong graph. But solving, we could simplify it. All right, so put that in the equation editor. You're putting this under y sub 1, y sub 2. You're going to have to figure out your window. And then you're going to get an intersection that looks like this. I need to know what the time is. So I would count from like 10,000 to 20,000, counting by like 10 to, let's see. How do we go?
I
10,
got 11. Oh, sorry.
counting by what, 1,000? What'd you get?
I got 11.78.
So it's about 12. So the Nikkei index reached 15,000 after about 12 years. And if you wanted to give the actual year, it'd be or after the year 2002 from the problem. All right, does anybody need the window read again?
Can you read it again, please?
Okay, anybody get a good graph where you can read the window?
Yeah, I can read mine.
Okay.
For my X min, I got 0. For my X max, I got 100. For my X scale, I used 1. For my Y min, I used 0. My Y max was 16,000. Going at the Y scale is 10, and then the X rest is 1.
So just remember, if your Y value is 15,000, you know that's a horizontal line, right? Because you're using two different graphs. And so it helps you out with your Y min and Y max. So I said that my Y min was 0 to 20,000. You heard how different hers was than mine.
Yeah, as long as it's above the 15,000, you can get like a good image of it.
Yeah. Yeah, exactly. So yeah, if it's somewhere below 15,000, you're not going to capture the intersection. All right, now let me explain probably what I'm going to let you go to your Math Wizard teams. We're out at school like in about 10 minutes, but I want you to go in there and get started. Remember that practice I gave you that had the E numbers in it? I hadn't taught the E numbers. Don't do that, because when we come back from spring break, I'm going to have you do that as a review. So we'll go back to that and do those E number problems. And yeah, so I hope you guys have a great vacation 2 weeks. I won't see you for a while. Just a reminder that if you're 11th graders, go ahead and practice the CASP if you have time. Practice those problems. I did make an assignment due on April 5th. So anyhow, in the Math Wizard teams, what I would do is if there's any questions about 13.2, ask. If not, go ahead and get started on 13.3, or I don't really care what you work on. But I will take attendance in the Math Wizard teams. Okay, I'll see you in your teams. We're not reporting back. I'll see you in the teams.